Hi guys, now I'm going to explain about active immunization and how does vaccine works. Okay, so first of all, vaccine are produced by using either a weakened or killed pathogens, weakened or killed pathogens, which is designed to mimic the natural infection process. So when a vaccine is administered, it introduces the pathogens antigens into the body. So it introduces the pathogen into the body, which is recognized. It is then recognized as foreign. So by the immune system responds to the antigen by initiating an immune response. So this process involves a series of steps that lead to the production of number of a specific antibodies, which can identify and neutralize pathogens. So the first step in the immune response is the initiation of the primary exposure to the pathogen via the vaccines. So the introduction of the antigens, it activates specialized cells called ABC or antigen presenting cells. Antigen presenting cells or APCs, which are found in different tissues throughout the body. So APCs such as um, dendritic cells, macrophages will engulf and digest the antigens. So as this happens, the antigenic protein is degraded, degraded into smaller fragments or peptides, into smaller fragments or peptides. Next, the APC will present the degraded antigenic protein to a specific type of helper T cells. So it will present to the specific types of helper T cells, which also known as CD4 plus T cells. So the T cell receptors on TH cells will recognize that antigen and also bind to the surface of the APCs, which stimulate the response. So the TH cells will interact with naive B cells that has never encountered the antigen before. So B cells are specialized cells that produce antibodies. Yeah. So the interactions of the TH cell with the naive B cells will stimulate the naive B cells to become mature. It stimulates the B cell to become mature and into a plasma B cells. So plasma B cells are highly specialized cells. So plasma B cell is highly specialized cells that will produce matches into plasma B cell, and it will produce and secrete vast amounts of antibodies that have high affinity towards the antigens. So the antibodies produced by the plasma B cells will circulate in the bloodstream. The antibodies will circulate in the bloodstream and bind to the pathogen, marking it for destruction. So the final steps in the immune response is the development of memory B cells. So memory B cells are long-lived. Is long-lived. That will remain in the body after the initial antigen exposure. So they actually remember the antigen and can produce a much faster and stronger immune response to subsequent encounters with the same pathogens, providing immunity against further infections. So in summary, vaccine works by priming the immune system to respond to specific pathogens. So the introductions or of weakened or killed pathogens into the body triggers an immune response that leads to the production of specific antibodies against it. So the generations of memory B cells ensures that if the same pathogens enters the body again, the immune system can respond quickly and prevent disease. Then, next, the immune system of a human body also consists of various cells and molecules. Let us see what happens if the pathogens attacks the body for the second time. That's a secondary exposure. When a pathogen attacks the body for the first time, the immune system produces a response that aims to eliminate the pathogens. So this primary immune response is usually slow and weak. So this protein is slow and weak. It is their first time encountered the pathogens. However, uh, as the immune cells and molecules, because why it's slow and weak, because it needs time to recognize. It needs time to identify the pathogens. And however, upon exposure to the same pathogen a second time, the immune system can rapidly respond. So this is because the immune system has already encountered the pathogen before and has developed memory, memory cells, and that can quickly recognize and destroy the pathogen. So this is why a second exposure to the pathogen often results in either no symptoms or milder symptoms. So this often usually no symptoms or milder symptoms. So when a person is vaccinated against a pathogen, the vaccine, like I said, it contains a weaker or inactivated form of the pathogens, so that can stimulate an immune response. So this process then leads to the memory B cells. So upon the exposure to the pathogen, the memory B cells get activated. Memory B cells activated and differentiate into antibody secreting plasma cells. Antibody secreting plasma cells. So these plasma cells secrete large amounts of antibodies into the bloodstream, which can quickly identify and neutralize the pathogen, preventing it from causing further infections. Antibodies attack pathogens through various processes. So there are various processes by which antibodies can attack pathogens, which is through opsonization. So opsonization involves the binding of antibodies to the pathogen surface to bind pathogen surface, which enhance its identification and elimination by phagocytes. Then there's also neutralizing process. Neutralizing Neutralizing antibodies will bind to a virus or toxin and prevent it from entering or affecting body cells. And then next is it agglutinations. So agglutinations, the antibodies can bind to multiple pathogens to form immune complex. Which can be easily eliminated by phagocytes. So finally, due to the persistence of memory B cells, a person who has been vaccinated or previously exposed to a pathogens can develop long-lasting immunity against the pathogens. So this immunity can last for many years and prevent them from getting infected again. So that's all from me. Thank you for watching.